Introduction to confidence interval. A confidence interval is an estimated range of values. In this case, the mean is unknown and the population standard deviation is known. We will use this formula to find the confidence intervals.
Okay, so now we will see the formula of the confidence intervals. The formula is x var minus the margin of error, which is E, is greater than mu, and then mu is greater than x var plus the margin of error. To find the margin of error, your formula is C times alpha divided by 2 times sigma divided by square root of n. And to find the C, you will have to do x bar minus mu and all of that divided by sigma divided by square root of n.
Hello, today we're going to show you how to do two problems of the confidence level intervals. First, we're going to do example number 1. So this is the problem that we have, and I'm going to read it very fast. In a random sample of 50 patients, the average for the sample is 75.4 beats per minute. Assume that the population standard deviation is of 12.2 beats per minute. Construct a 99% confidence interval for the average heart rate of the population. So here what we have to do, we have to use the 99% confidence interval. Over here we have the formulas and we just have to find what this is. So I'm going to show you over here how you can find it. First, we have to have this chart without the information that is in black. These are the 3 percentages that are the most common when talking about a confidence interval or a confidence level. So the first column is confidence level, which is 1 minus the significance level. Over here we have the significance level, which is what was left after you subtracted. And then we have the significance level over 2, and that is a decimal point. The answer that you get in the third column is what you're going to look for in the chart that is appearing right now on the screen. So you just look for example, if you're looking for the 99, you're going to look for the 0.005, and now you're going to get the critical C. And this is the formula for the critical C, and we just have our number. So to solve this problem, it's going to be very easy because we already have the critical C. So we're just going to solve it, and later on in the video you can see another problem when you don't have one of the 3 most common percentages of the confidence level. So now Ana Sofia Rivas is going to show you how to solve this problem.
To find our critical intervals, we have to subtract the E from the x bar. And to find our E, we have to multiply our critical C times the standard deviation over the square root of our average sample. So what we're going to do first is going to arrange the data the problem is given us. As we can see, our problem is giving us the sample, which is of 50 patients, and our x bar is going to be the average from the sample, which is 75.4. And our standard deviation is going to be of 12.2 ppm. So what we're going to do next is rewrite our formula to replace the data in it. So we can see we're going to place first our critical C, which we already got from the table we did at the beginning. So we're going to take the 2.5. 2.575 times our standard deviation, which is 12.2, over our square root of the sample. By plugging all this information in our calculator, what we get from E is 4.44. So what we're going to do to get our confidence interval is subtract this from our x bar, which is 75.4 minus 4.44, and then we're gonna add it to the x bar, so it's 75.4 plus 4.44. By plugging all this information in our calculator, what we get from E is 4.44. So what we're gonna do to get our confidence interval is subtract this from our x bar, which is 75.4 minus 4.44, and then we're gonna add it to the x bar, so it's 75.4 plus 4.44. Once we have subtracted and added the E from our x bar, this is our final answer, which will be our confidence interval.
Hi, this is our example number 2. A scientist wants to find the mean of a vaccine. It's normally distributed in humans with a 92% confidence level. The population has a variance of 36, and we take a sample of 10 patients out of the 36 with an average of 25. We have to find the confidence interval for the mean and the margin of error. To do this first, we have to find the confidence level of 92%. We are used to finding the confidence level with the normal ones, with 99, 95, and 90, but this time it's 92. So what we'll have to do is step to this chart. And you have a confidence level of 92%. So the 92%, we have to subtract a 1, and this is 0 alpha. So you can do 1 minus 0.92, and that will give us 0.08. And as you see here, that's your alpha. But in this one, you have to divide the alpha by 2, and that will give us 0.04. You will look for your 0.04 in your chart, and then you will get a 1.75, and that is your C.
Our confidence level is 92%. Our sample is 10, the X bar is 25, and our critical C is 1.75. To find the standard deviation, you have to do the variance, which is 36 square root, so it's 6. So now you just put it on the equation, which is 1.75, with the standard deviation and the sample square root. So this will give you 3.32, and now you have to pass it to the other formula to find the margin of error, which is X bar, which is 25, minus the E, 3.32, mu, and you do the same, just with positive. And this is your final answer.
Conclusion. This project did not change our lives, but did help us in the matter that we are getting close to our final exam.
It was really helpful to review a topic that will be in our final exam, and this led us to remember all the topics that we have seen in class.
We also learned to manage our time correctly. We all have different schedules and after-school activities.
We like this project better than the last two.
We learned new things, like how to find a range of values, and this will help us in the future.
This might not be as useful in our careers, but maybe we will use this in our future jobs.
We had fun this semester, and we believe that in our future financial decisions, we will think of this course.
Thank you.